So the next equation for polars that we're going to start graphing are going to be what's called polar roses. Now essentially a polar rose is just going to look like a flower. Now your flower is going to have different appearances. They're going to have different number of petals. The spacing between each petal is going to be different, and the petals are going to start in different locations depending on what type of equation you have. Sometimes the petal might start off at the 0-degree mark. Sometimes the petal might start off at some other angle here, just like we have in this picture. So every single flower is going to be different. Now the first thing you need to be able to do is tell whether your equation is going to be a polar rose or not. Now the best way to tell an equation is a polar rose is that your equation is going to look very similar to a polar circle. Now the difference is that the coefficient of theta is going to be something other than 1. So the general forms of a polar rose are going to be positive negative a cosine b theta or positive negative a sine b theta. If b is 1, if the coefficient of theta is 1, you're going to have a circle. However, if the coefficient of theta is something other than 1, you're going to have a polar rose. Now, once you figure out that you're going to have a polar rose, the next thing you need to do is you need to figure out how long is each petal going to be. In other words, if you're going from the pole to the end of each petal, how long is that going to be? Now, this is actually really easy to figure out. The length of each petal is just going to be your a value. Doesn't matter whether your a value is positive or negative. Whatever your a value is, whatever the coefficient of cosine or sine is, that's going to be the length of each petal. So in this case, the distance from the pole to the end of the petal is just going to be your a value. Now, this is probably the most difficult thing to figure out, is going to be the starting angle of each petal. Because again, sometimes your petal might start off at the 0-degree mark, sometimes your petal might start off at some other angle. Now, if you have cosine for your polar rose, your angle, your starting angle, is going to be 0 degrees. If the equation is going to be sine, the starting angle for the first petal is going to be 90 degrees divided by b. So what you're going to need to do is, if you have sine, you need to take 90 degrees divided by the coefficient of theta, and that's going to give you the starting angle. Alright? Now, the next thing you need to figure out is you're going to need to figure out how many petals there are. Now, there's two situations, and everything's going to be based on the coefficient of theta. If the coefficient of theta is even, to figure out the number of petals, you're going to take your coefficient and multiply by 2. So if b is even, you're going to take 2 times b, and that's going to give you the number of petals. However, if b is odd, in other words, if it's 3, 5, 7, if it's going to be an odd number, then that odd number is just going to be the number of petals. So if your coefficient is even, such as 2, 4, 6, 8, the number of petals is going to be twice that. However, if b is odd, such as 3, 5, 7, 9, b is just going to be the number of petals. Now, the final thing you need to figure out in order to draw your flower is going to be the angle between each petal. And the formula to figure out the angle between each petal is going to be 360 degrees divided by the number of petals you have. So in order to graph a polar rose, these are going to be the 4 things you need to figure out. The length of the petal, the starting angle, how many petals you actually have, and what is the angle between each petal. In other words, what is the distance from one petal to another petal.